Good evening and welcome to the Japan Earth Observer for July 24. This is a news roundup for the past week in the space, Earth observation, and geospatial industries in Japan. I'm Robert Cheatham. I run a research and strategy consulting firm called Apica Labs, and I write the Japan Earth Observer newsletter. Tonight we're going to lead off with new details on Japan's OHISAMA space-based solar satellite. This week, Japan Space Systems, JSS, which is a nonprofit research foundation, shared mission details for OHISAMA, which is a 180 kilogram satellite expected to launch during FY 2026 into low Earth orbit. The satellite will demonstrate a 5.8 gigahertz microwave power transmission capability from orbit to a ground target. If successful, this will be the first orbital demonstration of space-based solar power beaming. On the ground, a receiving station in Suwa in Nagano Prefecture that consists of 13 antenna arrays spread across 600 square meters will capture the microwave signal and convert it back into usable electricity. While this system, a demonstration version, will only generate a modest 720 watts, the long-term vision is for a 1 megawatt station by the 2030s and a 2-kilometer orbital array generating 1 gigawatts by the 2050s. This is not new technology. The project has been under development since the 1980s, but persistence pays off, and Japan is currently considered to be in the lead to operationalize this capability. The most recent milestone is a transmission test from an aircraft at 7 kilometers altitude a couple of years ago. Now, a key challenge for this kind of thing is precision. A satellite in low Earth orbit is traveling at 28,000 kilometers per hour. It will need to keep a microwave beam locked onto a ground receiver station with an error margin of less than 0.001 degrees. One additional hang-up potentially for OHISAMA is that it's slated to ride on Space One's Kairos 5 rocket. However, the first 3 Kairos rockets all failed by blowing up before reaching orbit, most recently in March this year. The OHISAMA folks, JSS, who's behind it, have to be hoping that Kairos 4 and 5 are more successful. Speaking of successful tests, the JAXA Epsilon S second stage engine test was successful. This happened yesterday with a static fire test of the M35A solid rocket motor at Tanegashima Space Center. The test firing was a key milestone for JAXA in its effort to return the Epsilon rocket to regular flights. Epsilon is one of 2 rockets that JAXA has developed. The H3 is the flagship medium-lift rocket that also recently returned to flight after a launch failure in December. The Epsilon series is a smaller, solid rocket counterpart that is used as both a sounding rocket and for sending small satellite payloads to orbit. The first stage is the same SRB-3 solid rocket motor that's used as a booster for the H3 and is seen as fairly reliable. For the next generation Epsilon S, JAXA had developed a new engine dubbed E21 for the Stage 2. The new design would have provided additional thrust to boost larger payloads into orbit. However, this new engine has failed in each of the last 2 ground firing tests in 2023 and 2024. As a consequence, Epsilon rockets have not successfully launched since 2021, creating a years-long backload of payloads waiting for a launch slot. The problem has been serious enough that JAXA has paid Rocket Lab, a private company, to launch some of these payloads on Electron rockets from New Zealand, which is not a good look when having an autonomous sovereign launch capability is a key objective for Japan's launch program. It's also not helping JAXA reach its goal of 30 launches per year by the early 2030s. So a few weeks ago, JAXA announced it would be returning to the previously successful Epsilon second stage motor, M35. There are some improvements, so it's being dubbed M35A, but because it's changing, it needs to be retested. So that was Thursday's big event. Nothing blew up on the live broadcast of the 132nd test, so that's good. JAXA had 250 measurement points for the test, though, so we'll have to wait and see what the data analysis shows. In any event, JAXA wants to see a return to flight for Epsilon by the end of FY 2026. This will be good, but it's not ideal. JAXA had been pursuing the new E-21 motor design because it wanted to increase the launch capacity of the Epsilon rocket to 600 kilograms. By falling back to the more proven M35 design, they'll reduce the launch capacity to 400 kilograms. I expect they'll continue to pursue the newer motor design because it does have that significant 50% payload improvement. IHI is evaluating hyperspectral satellites from the Finnish Kuva company. They announced a MOU this week to explore building and operating Kuva's Hyperfield 2 satellites, including the potential for manufacturing them in Japan. About 20 Hyperfield 2 satellites would be enough to provide daily coverage of about the 20 million square kilometers across Japan, neighboring countries, and surrounding ocean areas. IHI has already begun to procure SAR satellites, synthetic aperture radar, from another Finnish company, ICEYE, as well as thermal imaging satellites from SatView, and radio frequency and VDES satellites. So Kuva will be a fourth service or capability that IHI hopes to build out. They are just starting to operate the Hyperfield 2 satellites, and they plan to operate 100 of them by 2030. The newer satellites will add shortwave infrared, or SWIR, to the very near-infrared Wiener wavelengths supported with the previous Hyperfield 1 version. The Kuva satellites are intended to be part of essentially a multi-sensor sovereign Earth observation constellation that IHI wants to build out that will include up to 100 satellites over the next few years. Some more bad news for iSpace. NASA has confirmed that it's canceled its contract with Draper for the CLIPS CP12 task order due to delays associated with the lander redesign. This is bad news. Draper is a nonprofit based in the United States, but it had subcontracted developing the lander to iSpace, the Japanese lunar lander company. This contract was awarded back in 2022 for a lander that was intended to be sent to the far side of the moon with a suite of pretty unique instruments that NASA was developing. The lander was originally supposed to launch last year, 2025. There have been multiple delays and redesigns, though, most recently with iSpace US merging its original Apex and Series 2 landers into a new Ultra design, which was forced on them by delays in the engine delivery by a third-party company. This had pushed the projected launch and landing date out to 2030 or 2031. NASA seems to remain committed to the 3 science payloads, which included a seismometer, heat flow sensor, and another sensor around the electromagnetic fields, and may find additional CLIPS rides. iSpace is looking to potentially bid on the CLIPS 2.0 RFP that came out earlier this year. In better news for iSpace, however, iSpace Europe, their European division, won a 65 million euro ESA lunar rover contract known as MAGPIE. MAGPIE stands for Mission for Advanced Geophysics and Polar Ice Exploration. iSpace already had a Phase 1 contract for design development, and Phase 2 will bring this to actual development and delivery. The 65 million euro contract will cover the remaining rover and payload development, manufacturing, testing, transportation, and surface operations. This has already started as of July 1st, after the design review was completed, and MAGPIE, assuming it's successful, will investigate solar south polar water ice stability and water ice in the regolith. It expects to fly on iSpace's Mission 4 lander in 2029, combining ESA's science capabilities with JAXA's high precision lunar polar landing capabilities that iSpace has been building out. JAXA has been recently promoting its SatDyne orbital test facility. This is kind of a unique test facility. This week they released some video and documentation on how it actually works. It's called the SatDyne Orbital, it stands for Satellite Dynamics, Orbital Service Test Facility. It's a ground verification system for developing on-orbit servicing technology. So this facility is able to test satellite servicing mechanics before launch. The types of things it helps with are missions that are engaged in debris removal, refueling, repairs, and so on. This kind of on-orbit servicing is a key market that JAXA is supporting, and its lead company, Astroscale, is probably the main startup firm doing this kind of work in Japan. The SatDyne facility is ground test infrastructure behind that effort. It is it was originally funded in 2019 and went into operation in 2020 and has been extended and improved on an ongoing basis since then. Includes it's really a series of robotic and digital simulation facilities for attempting complex or risky missions on the ground, so that those complexities can be worked through before a satellite is sent into orbit. Not so many deals this week, but a few still. Digital Blast signed a Starlab space station reservation. It's the second Japanese company reserving commercial space station capacity with Starlab. Digital Blast is a Tokyo-based company. Starlab is Starlab Space, company developing commercial space station capability. The intended payload is going to be an onboard computer being developed with JAXA funding for on-orbit data center technology. The effort is led by Digital Blast's affiliate called Space Blast. Digital Blast also is developing microgravity, life science R&D equipment and platform services intended for future commercial space stations. The first reservation holder for Starlab was Mitsubishi Corporation, announced in January, and Mitsubishi is actually one of the investment backers for the Starlab effort, alongside Airbus, Voyager Technologies, MDA Space, and others. JAXA has selected a couple of firms to do advanced R&D work around generating lunar propellants on the lunar surface. The first of these is Kurita Water Industries. They've been selected to test water purification components for lunar propellant production plant. They're going to test removal of ammonia and methanol, which are expected to be contaminants to water that is extracted from lunar regolith. Evaluate degradation factors, and then conduct some long-duration performance tests. These are all due this year and build on Kurita's previous work in 2024 and 2025 under a similar program. The other lunar propellant effort is funding for JGC Global to actually build a propellant production plant. JAXA selected them to advance to more detailed design and prototyping for a terrestrial demonstration plant supporting generation of lunar propellant. So JGC is going to continue to the design work with a demonstration plant, assess the operational and construction risks, and support international agency technical studies. as well as conduct water extraction experiments from lunar regolith simulants. This is expected to have results completed during fiscal year 2027, so that's March 31st next year. Same current fiscal year, just like the Kurita project. And like Kurita, also it advances some work that has been done over the last couple of years on basic design work. And with that, we'll wrap things up. That's it for the week. If you like what you see, please subscribe, and you can also get regular news roundups and in-depth stories like this through the Japan Earth Observer newsletter at japanearthobserver.com.